Good day, everyone. We're jumping to 6.4 using the quadratic formula. Previous lesson, we touched on the quadratic formula, well, at least quadratic relationships, but now we're actually going to get into the quadratic formula itself. It is April 26th of 2020. It's grade 10 math. Mr. Benjamin here. Learning goals for this lesson. So we're going to determine the best approach to solving different equations. For example, we know factoring, we can isolate, assigning x values, x equaling what. There's going to be many situations where we try an approach and it might not work for whatever reason. So we have to be able to determine what another solution is. What can I try first? How can I recognize what problems are going to work out differently? How do I know when to factor? How do I know when to isolate? How do I know when to use a quadratic formula? That takes us to the next step of solving problems using the quadratic formula. So to start us off, this monster right here, it's not the biggest equation you'll ever see in your life, but it's pretty big. It is the quadratic formula. So x, which generally speaking will have two roots, or zeros, makes it easier to think about it, will be equal to negative b plus or minus, and that gives you the two roots because it can be positive or negative, the root of, in total, so I can even put a square bracket around here, the root of b squared subtract 4 multiplied by a multiplied by c, and all of that is divided by 2a. Okay? Now, keep in mind, these values, a, b, c, they come from standard form. Okay? So, a, let's find my b's, b, and c. Okay? So if we're ever in a situation where we have an equation in standard form, we can't factor it to find the zeros, we can plug in all the values into our quadratic formula and find the solutions. Now in many cases, like I said, you're going to get one positive, one negative. In many cases, you'll end up with a situation, for example, if it's a word problem asking about time. Time can't be negative. Cannot equal a negative. That's impossible. So in that case, you'd reject one of those answers. But for different situations, for distances, for example, you can have a negative distance if you are taking it away from a total value. So it's not always the case that the negative will be rejected, but in many cases it will. So when do you know, or how do you know when to factor? How do you know when to isolate, etc., etc.? So looking at this situation here, this function, we have x squared subtract 7 plus 6. So these are my a, b, and c values. And I know in this case, a equals 1. So whenever a equals 1, the first thing that comes to my mind is sum and product. Sum, which is the b value, product, c value. What do we have here? B is 7, it's negative 7, and c is positive 6. So what two values add up to negative 7, and when you multiply them together, give you a positive 6. So since it's positive, I know it's going to be negatives, because two negatives together, or two positives together, either way, but I know it's going to be the same sign. And I want to get up to 7. So it could be 3 and 4, it could be 2 and 5, it could be 1 and 6. If I do negative 1 and negative 6, when you add those together, that's going to be negative 7. So that checks out. Negative 1 multiplied by negative 6 equals positive 6. So that checks out. So what do I do for this case? Well, I know my x, it's going to be minus 1. And I'm going to have x subtract 6 equaling 0. So to solve each one of those, I'll have x equal to 1 or x is equal to 6. So I did not need the quadratic formula for that. You could easily put these values in. You could put your a, b, and c, so a was 1, b was negative 7, and c was positive 6, into a quadratic equation, and you should get these values. Test that out, see if you get them. In many cases, if b is equal to 0, you could just isolate your a value, or isolate your x. Okay? So we've got a here, there's no b, and I have two c's. So what I'm going to do is collect these like terms. I'm going to bring the negative 10 over. So I'll have 3x squared is equal to 8 plus 10. 3x squared is equal to 18. Divide each side by 3. X squared is equal to 6. So if I take the root for both sides, what the heck do I get when I take the root of 6. Well, I'm going to use a calculator for that because I can't really think of it. So I end up with root of 6 equaling 2.4. I'm just going to do 2.45. Now, if you take this value, 2.45, and you square it, that'll give you 6, approximately. Okay? But if you take negative 2.45 and square it, that'll also give you 6. So my solution is two values. Can be either, I'll write it, I'm going to get rid of all that, write it right here. So, solution, x can equal negative 2.45 or positive 2.45. Now the other way, because we know we have a decimal, we might not want a decimal, we can just leave our answer as root 6. X can be equal to root of 6 or root of negative 6, because these things are the same. What I should actually do is correct where I've put the negative there. There you go. That's more accurate. Okay, so either one of these should be okay. What if you have a situation where you're looking at a function, or an equation, trinomial in this case, and I think, okay, my a is equal to 1. I can do sum and product. Sum of 5, product, negative 2. So, I need to think about two values that give me a sum of 5 and a product of negative 2. For the life of me, I cannot think of two numbers aside from 1 and 2 that give you 2 when you multiply them together. But 1 and 2, no matter what you do, cannot equal 5. Cannot equal 5 when added. Okay, so that's a problem. So I can't just factor this out. The solution is going to be a bit more unique, we'll say. I guess that's the right word of putting it. Anyways, I'm going to get rid of this. My a is still equal to 1, but I'm going to write that over here. So a is equal to 1. B, what was my b? B is equal to 5. And c is equal to negative 2. Okay? So these values come from here, here, here. I have a, b, and c. What I'm going to do... I would have copied it, but it's kind of busy, so let me just write it out. Quadratic formula. So my roots of x are equal to negative b plus or minus root b squared, subtract 4ac. All of this is divided by 2a. This is really important. When I was young, I used to forget that all the time, and of course your solution is not going to be correct, right? So I have a, I have b, I have c. I know my three values. All I have to do is sub them in. X is equal to negative b. B is positive 5, but becomes negative here. Plus or minus root b squared. So it's 5 squared. Subtract 4 multiplied by 1 multiplied by negative 2. Okay, all of this because my a, or because my a is 1. 2 multiplied by 1. All right. So far all I've done is sub these values in. Now, I'm gonna want a little bit more room, so I'm gonna erase these. Draw them here. A equals 1, b equals 5, c equals negative 2. Alright, so now that I have all my values in, all I have to do is solve. So what I can do is, I can definitely solve this portion here. Okay, so x is equal to negative 5 plus or minus root 5 squared is 25. Subtract 2 minus 1 is 2. Subtract 4, that gives us a positive positive 8. When you add those together, you should end up with 33, I believe. And not to forget that all of this is divided by 2. Okay, so now my x can be separated to two ways. X can be equal to negative 5 plus root 33 all divided by 2, or x can be equal to negative 5 subtract root 33 all divided by 2. The reason for that, again, comes down to this plus or minus, because my answers can be positive, or I should say my answer can be positive or negative. Okay? So I'm going to solve each one here. Now, root 33, let me just calculate that. All right, so root 33 gives me about 5.7. I'm just going to round. Let's section this off here. So x can be equal to negative 5 plus 5.7 all divided by 2, and x equal to negative 5 minus 5.7. So that 5.7 is just root 33, and that's still divided by 2. So on the left side, I'm going to have 0.7 divided by 2, and that's going to be equal to 0.35. On my right side, I'm going to have x is equal to, is that 10.7? And 10.7 divided by 2, we'll say it's 5.35. So in this case, I have two positive values. Previously, I was saying you could have one negative value. Oh, no, sorry, this one is negative. Let me undo all that. I forgot my negative sign. My mistake. Equals negative 5.37. So my solutions were 0.35 and negative 5.37. So again, depending on what the situation was asking, if there was a word problem associated with it, you'd have to look at these two values and think logically. Okay? But at this moment, both of these are acceptable solutions. In many cases, you're going to end up with larger questions that you have to expand and distribute like we've done before. So for example, in this case, I've got 3x multiplied by 5x subtract 4 plus 2x equaling x squared subtract 4 multiplied by 3, or excuse me, 4 multiplied by x subtract 3 in brackets. So we're going to have to distribute these values. Right? So this is going to equal, I've got 15x squared subtract 12x plus 2x equaling x squared subtract 4x subtract 12. Okay, so I have, see what kind of like terms I have here. I've got x here, I've got x squared, or x squared and x squared. I've got x's there, I've got more x's here, and I've got the lone constant of 12. So what I should end up with, if I rearrange, 15x squared, bring this guy over, becomes subtraction, subtract x squared. I got negative 12x and 2x, and then negative 4x. I'll write it all out. Once I bring over that 4x, it becomes positive. And that will all equal, you know what, let me bring over the negative 12 as well. So it becomes positive 12. Oh, no, it was positive 12 to begin with. My mistake, that distribution. Negative 4 multiplied by negative 3 equals positive 12. Okay, if I bring it over, I'll have a negative 12, and this all equals 0. Now I just have to collect my like terms. So I've got 14x squared. So what I got here, positive 6, negative 12, so it should be subtract 6x. And I'm left with negative 12. All right, so at this moment, actually, what I can do is I can still factor this out. I can take 2. I can take 2 out of all this. So 2, bracket 7x squared, subtract 3x, subtract 6. Yep, and this all equals 0. Now that factor, the equation is still the same, so you don't have to worry about that. What I can say is I have an a, b, and c value now. So a equals 7, b equals negative 3, and c is equal to negative 6. So I have these three. I can try doing a multiplied by c. Now what will that give me? Negative 42. Sum of 3 product of negative 42. I don't think there's any two values that will work for that. So I can't just factor this, right? So I'm going to get rid of that. So I have to use quadratic in this case. Do I have space? Yeah. You know what? I'm going to have to go to another page. So I'm going to keep that in mind. A, B, and C, 7, -3, -6. A equals 7, B equals -3, C equals -6. So, let's write out the quadratic formula. The more you write it out, the easier it is to remember. Do it in white. X is equal to -b plus or minus root b squared, subtract 4ac, all divided by 2a. All I got to do, sub in these values. I don't want to sub in a, I want to sub in 7, -3, and -6. All right. X equal to, my b is -3, so it'll turn into +3, plus or minus root -3 squared, subtract 4, multiplied by 7, multiplied by -6. That's going to be a huge number, so we'll have to deal with that when it gets there. What am I missing? All divided by 2. What's my a value? All divided by 2 multiplied by 7. So everything's going to be divided by 14. It's going to be kind of tough, but we'll get through it. Okay. X is equal to 3, plus or minus. Let's see what we can solve out of here. -3 squared is 9. Subtract 4 multiplied by, okay. I'm going to have to calculate this. So when I calculated it, I ended up with -168. So these two together are going to give me a positive. I'll write that on the next line. And this is all divided by 14. So x is equal to 3 plus or minus. When I add these together, I should end up with, all right, let's write this out. 9 plus 168 equals 177. 9 and 8, 17, yeah. So, root 177 divided by 14. Now, at this point, I'm going to go to another page. See if I can just copy the part I want. Alrighty. So, I can take the root of 177. I might keep it there for now. I'm going to write it out. X is equal to, remember, we have 3 roots, so plus 177. X equal to 3 subtract 177. Both of these are divided by 14. And that is the roots. Now, the part I have difficulty with is taking roots. Give me just a second calculating it. So I've got 13.3. So x is equal to 3 plus 13.3 divided by 14. And here x is equal to 3 subtract 13.3. That's also divided by 14. So this is going to be a really small number. This is going to be a bigger number, slightly. 16.3 divided by 14. Let's see what that gives me. It's going to be 1.2 or something like that. I got 1.16. And then here, I'll end up with what? Negative 10.3 divided by 14. It's going to be like 0.75 or something like that. So 10.3 divided by 14 is equal to negative 0.74, round up. So those are my two solutions. So we'll call these roots. Alright? And they're both viable because we don't know what the question was asking for, so a negative could be viable in this situation. Well, gotta go back a couple slides. Now, we're going to be a little out of order, but that's okay. We do have word problems associated with quadratic formulas as well. So in this case, we have a picture measuring 12 by 20. We wish to add a border of equal width around the picture, while the area of the frame must equal the area of the picture. Determine the width of the border. Okay, so we're looking for the width of the border. Now, we know what the picture is. Let's start with drawing. It's not to scale, but that's okay. 12, 20. We want to put a border around it, and the border has equal width all around it, okay? So we can call this x, because we know all of these are going to be the same. All right? So this distance here would be 12 plus 2x, because we know that's 12, and we know this is 1x and this is 2x. Okay? And the area underneath it, it's going to be 20 plus 2x. All right. I'm going to copy this picture. I'm going to go to a new slide because I need a bit more space. Past the 20-minute mark, I apologize. Try to make this quick. Okay, now we know the picture. Area of the picture is equal to 12 multiplied by 20 centimeters, which is 240 centimeters cubed. Okay. We know that the area the area in total will be equal to 20 plus 2x multiplied by 12 plus 2x. But we need to find out what this x value is. Okay, and in order to do that, we have to have some sort of value to associate this with. Now, what we can say is area total is equal to the area of the border, subtract the area of the picture. And we know the area of the picture. The area of the picture is right there. Okay? So, what we're going to say is, we're going to write this out again. So the area of the border plus the picture is the total area. So, if we rearrange this, the area of the border, excuse me, let me write that again, will be equal to the total area, subtract the picture. Oops, not the B. And that's going to look something like this. 20 plus 2x multiplied by 12 plus 2x, subtract 240. So we got this measurement, centimeters squared, from there, and this measurement from here. Okay? Now, that's just setting up our equation. Let me copy this, go to the next slide. Done. Now that we have all this information, we can try to sort of solve what we're doing here. So we have this function here. We can FOIL this out. Okay? We know 20 multiplied by 12 will give us 240. First outside, 20 multiplied by 2x will be 40x. And we have in the middle 2x multiplied by 12 is 24x. And then we've got 2x and 2x, and this is 4x squared. And this is still all subtract 240. Okay? We have some like terms here. This positive 240 and this negative 240 can cancel out. So what are we left with? We've got, let's add this up. 40x and 24x should be 64x. Plus 4x squared. Alright, and I'm just going to rearrange that to 4x plus 64. Oops, 4x squared plus 64x. So, our border is going to be equal to that. Okay? Now that we have that information, we need to kind of look at what we remembered about the area. I'll go back to the question. Area of the frame, which is the same as the border, must equal the area of the picture. Okay? So, area border equals area picture. So, this 240 is equal to 4x squared plus 64x. That doesn't look like 64x. Try that again. Alright, now, all we have to do is rearrange this value. So, let me copy this, go to a new slide. Oops, cancel. Let's try that again. Let's rearrange. So, 0 is equal to 4x squared plus 64x minus 240. All I did was bring this around here, so now it's in standard form. Okay, I've got an A, B, C. Can I factor? I think I can factor. Can I factor out the 4? 4 goes in 64, 16, and that's 60. Yeah, so 0 is equal to 4x squared plus 16 subtract 60, 16x. All right, so I've got sum and product. Can I do sum and product? Sum 16, product 60. Do I have any values that can fit in here? 12, 6, and 10? Okay. 6 and 10. I need to get to negative 60, so both of them have to be... No, one has to be negative, one has to be positive. That's not going to work. 5 and 12? That doesn't work. Okay. No factors. So what does that mean? Quadratic. So, A, B, C, 1, 16, negative 60. I think those numbers are correct. Let me just confirm. Looks like it. All right. Let's write out the quadratic. X is equal to negative b plus or minus root b squared, subtract 4ac, all divided by a. Sub in those values. My b is positive 16, so my b is going to become negative 16, plus or minus root 16 squared, subtract 4, a is 1. It's always great when a is 1. Negative 60. Ooh, that's going to be a big number. That's going to be a huge number. And a is 1, so I don't even need to write out the division anymore because a equals 1. All right, what is this going to look like? Let's put it on the next slide so we have some more space, okay? Not sure why it's 1x. I don't think that's possible, but that's okay. All right, let's work out 16 squared and this monster over here. All right, so x is equal to negative 16 plus or minus root 16 squared is 256. You got two negatives here, so that's going to be positive 240. 256 and 240 is 496. So x is equal to negative 16 plus or minus root. Now at this point we can separate this into 2. X is equal to negative 16 plus root 496. And x is equal to negative 16 subtract root 496. So what is the root of 496? Let me just work that out now. 22.3, we'll say. It's equal to negative 16 plus 22.3. X is equal to negative 16 subtract 22.3. Now, one thing I forgot, a is equal to 1, but I still have my divided by 2, so I've missed that entire step, see? Always used to forget that. My apologies. Hopefully you caught that. We're like, hey, Mr. Benjamin, you forgot that. So these are all divided by 2. Okay. So if I have negative 16 plus 23, it's going to be around, x is going to be equal to 3-ish. 16 subtract 22.3 is equal to negative 6.3. Divide that by 2. It's negative 3.15. All right. On this side, I'm going to have, is this going to be, oh, it's positive, my mistake, sorry about that. This side I'm going to have negative 16 plus 22.3. It's going to be negative 38.3. That's divided by 2. 38.3 is going to be like 19, 19.15. But this is negative, right? Now, if we look at these two values, our frame could either have a width of negative 19 centimeters or positive 3 centimeters. It's not squared, it's just centimeters. Which of these is more realistic? Can you have a negative distance for a frame? Possible? No. Therefore, our width is 3.5 or 3.15. Therefore, the frame width is 3.15 centimeters. All right, that was a long one. We're at 30 minutes now. Hope that was all clear. I know to make a mistake at the end there, but of course, if you have any questions, comment, email. All the best to everyone. Have a wonderful day.